Welcome to our channel, Future Aircraft Engineers. Today, we're exploring a critical system used in almost every modern aircraft, the hydraulic system. This topic is key for your EASA Part-66 exam, and understanding it will also help you during real-world maintenance tasks. Let's take off. A hydraulic system uses pressurized fluid to generate movement and force. It's like giving muscles to an aircraft, allowing it to raise the landing gear, move control surfaces, and apply brakes. The core principle is Pascal's law. Pressure applied at one point in a fluid is transmitted equally in all directions. This makes hydraulic systems powerful, reliable, and lightweight, perfect for aviation. A typical aircraft hydraulic system includes the following components. Number 1, reservoir, holds the hydraulic fluid. Number 2, pump, usually engine-driven or electric, pressurizes the fluid. Number 3, filters, remove debris to keep the fluid clean. Number 4, accumulator, stores pressure and provides backup power. Number 5, actuators, convert fluid pressure into movement. Number 6, valves, control the direction and flow of fluid. Each component plays a vital role. So, where a hydraulic system's used, they power the landing gear, allowing it to extend or retract. They move flight control surfaces like spoilers and flaps. They operate wheel brakes and even cargo doors on larger aircraft. In Airbus aircraft, for example, you'll see 3 separate hydraulic systems, green, yellow, and blue, each adding redundancy and safety. What happens if a hydraulic system fails? Aircraft are designed with multiple systems, so one can take over if another fails. Hydraulic fuses can isolate leaks. Warning systems alert the pilot or maintenance crew of low pressure, and accumulators help in emergencies by storing pressurized fluid. Proper inspection and maintenance of these components are critical for flight safety. Let's review quickly. Hydraulic systems use pressurized fluid to power many aircraft systems. Key components include pumps, valves, actuators, and reservoirs. They are used in flight controls, brakes, and landing gear. Remember Pascal's law, common pressure units like PSI and bar, and the purpose of each component. EASA tip: you may be asked to identify system components or explain redundancy in a scenario-based question. So understand the system flow, not just definitions.